Welcome back, everyone. Did you like those super cool space pictures? I thought it was awesome how the astronauts were like floating around and you could see the difference in mass, even though their weight, or the difference in weight, even though their mass didn't change, right? Which is why the one astronaut had an easy time lifting the other one, because his weight was different in space, even though he had the same mass. All right, I hope that you also caught when they dropped the bag of apples and the one apple, how they fell at the same time, exactly like our erasers did. And they explained it. I'm going to go over that explanation one more time. And then we're going to look at this really cool simulation online together. And there are two things for you to do on your own. So here we go. Force equals mass times acceleration. That's what we've learned so far. There's something called the acceleration of gravity. Gravity pulls everything, you, me, the table, the chair, that tiny little car I was playing with, my coffee cup, everything. It pulls everything that exists towards, or everything that has mass, towards the center of the Earth at the same rate, exactly 9.8 newtons. Because gravity pulls everything down at the same rate, it doesn't matter the mass of the object. Its acceleration is also 9.8. This is called the acceleration of gravity. So no matter what the mass of a thing, it will fall at the same rate as anything else because of that acceleration of gravity. If you're keeping a notebook, you might want to write that down for yourself. Otherwise, try and just save it in your head. The acceleration of gravity causes everything, because gravity pulls everything down with the same force, to land, to hit the ground at the same time. Doesn't matter its mass. All right, so man, we've done experiments. We've talked about Newton's second law. We've talked about how force equals mass times acceleration. And if you know the mass of something and the acceleration, you can figure out the force. Or if you know any of these two factors, you can figure out the other one. In your homework, I'm going to have you do just one problem of the math in which you figure that out together. Until then, however, I found this really cool simulation online. The University of Boulder, Colorado has set up a way for you, yes you, at home or anywhere you are, to play with these different elements on the computer and see how they affect things. So the rest of the time for today, I want you to, there's a worksheet you're going to fill out, and then you're going to make some predictions. Then you're going to go to that simulation website, which I'll show you right now. I'll show you both. And play with it. Play with it as long as you want to play with it. Play with it at least for 5 minutes. But have at it if you want to play with it for longer than that. Leave me a comment. Tell me what you think. Should we use more of these simulations or not in these classes? I would like to know whether or not you enjoy this. And then you're going to do that experiment worksheet at home or in the classroom yourself. That's what you'll be graded on today, those two worksheets. All right? So I'm going to screen share with you and show you where each of those are and show you that simulation website so that you're familiar with it. I'll walk you through how it works. And then we're going to be done for the day. Good job paying attention, everyone. I'm proud of you. You made it through a whole week of physics. All right, I'm going to share my screen with you. Here we go. So again, you are seeing my my Google desktop. Here we go. Scrolling through what we've done so far to this forces and motion worksheet and simulation. It says complete the worksheet first. Step 2 is then follow the link to the super cool online motion and force simulation to play with it and to test out your theories. So when you open up this and you push the open button, you'll get your own document that you can fill in. And I want you to read over the directions and make some predictions. You're going to look at if two different forces are pulling on a thing, who's going to move it the most. So for example, here we have a big blue guy and a little red guy. if they both pull on this barrel of candy, who's going to move it toward them? Is it going to go toward the blue guy or toward the red guy? And why? Hint, it has to do with the force they exert. Okay, I want you to think through that. You're going to answer those questions. And then you're going to go to this website. You're just going to click on the link like I just did. It's going to open up just like this. And in this super cool simulation, you get to decide who's pulling, where they're standing, and see how the barrel moves. So there's one answer right there. That prediction you'll get right. What if we have them at different places? I have that guy in and that guy out. Oh, he's not pulling as fast, but he's still able to do it. Here, you can turn on all those things and actually see. If you give this little guy a little help. Is that chat? Oh, look, there. I keep return, go. They are equal. We now have the equal amount of force on each side, and so it can't move at all. Pretty cool, right? All right, if you go back, there's actually 4 different simulations, and I want you to play with different ones of these. So here's the next simulation. You got this guy, he doesn't move. He's got a skateboard and a smooth surface. And you can choose to put whatever you want on top of that skateboard. It all has a weight. And if you choose the force that this guy pulls with. So if he is pushing 40 kilograms at 50 newtons, there you can see the speed of the acceleration. Now, if we add a little weight to that little girl, what's gonna happen? The speed is still accelerating, but not by as much. What if there's no friction, there's nothing to slow her down or stop her. So the amount of movement that they already had, she'll keep going. But if we reset it, we have our little guy here. Oops, let's take away that box. Push them with the same amount of newtons. See, where were we? We're at 50 before. Oops. She's not going very fast, is she? Because he pushed and let go, but it's weighs, the mass on top of this skateboard is way heavier. Now, if we want to make this even more exciting, we can add some friction to the bottom. We can actually change the amount of friction in the simulation. So let's have him push with about 50 newtons of strength. Oh, 50 kilograms and nothing happens. What if he pushes with 100 newtons of strength? Where's the 100? There we go. Still nothing happens. What if we have him push with 500 newtons of strength? Now something's happening, but the friction changes what happens considerably. We'll talk more about that next week. So I want you to play with this simulation for a little bit after you've done the worksheet. And then your other piece of homework for the day is right below it. Here's your daily final assignment for today. You're going to open up this worksheet and follow the instructions to create your own experiment, just like I made with the little cars. So there's a whole lot. Don't be daunted by the amount of directions. I just wanted to make sure you had everything you needed. So you know what you need, and then you know what to do, and then you're going to write up a little report for me. Now, this report is different from everything else you've done because I don't want you to do it in Google. Instead, I want you, while you have your experiments, to just have a piece of paper and pen next to you, or pencil, and you're going to be writing out what you find on that paper and pencil, on that paper. Once you've done, run your experiments and answered the questions that are in the worksheet on the paper, you're going to take a picture of it and you're going to email it to me. So all you need for this is your phone to take a picture of what you've written down, and then you're going to email it to me so that I know you've done it. I see that Capri has a question. Is that correct? They can't see me? Oh, sorry, guys. I was thinking you could see me and you can't. Anyway, so here, you're going to write a description of the experiment that you do. You're also welcome to draw. I didn't write that down, but I would be perfectly happy if you drew a description. You're going to tell me how far each object traveled, how much time did it take to travel the distance. Now I have a bonus challenge. If you feel up to the challenge, if you've had some algebra and you know how to do this, you can go ahead and figure out the acceleration for what you did, estimate a mass, and figure out the force that was used. If that's way more algebra than you've done before, that is also fine. Then I just want you to answer this question. In Miss Micah's experiment, the blue car had a mass of 0.5 grams and accelerated at a rate of 4 centimeters per second. What was the force she used? Remember, force equals mass times acceleration. So you are all going to be able to do that. That's a simple one. All right, those are your 2 assignments for the day. I'm going to stop screen sharing so you can see me one more time. Those are your 2 assignments for the day. I know that you can do it. If you have struggles with either one, go ahead and just send me an email or write them in the comments, and I will be checking periodically over the weekend also to get back to you before Monday so I can help you out. I hope that you have enjoyed these 3 days of physics, and I hope that you enjoyed our experiments today. I am really looking forward to getting the results of your experiments and seeing what you're able to do at home. I'm excited about that. Or in the classroom with your teacher. You are welcome to get all the help you feel you need. So have a great weekend, everybody. Enjoy the world out there. Keep your eyes open. Be thinking about mass and acceleration and force as you go through your weekend. And again, may the 4th be with you. Have a great weekend, everybody.